Alright, in this video we're going to learn about two things. One, defining Newton's first law of motion, and two, explain how an object's inertia relates to Newton's first law of motion. First, let's figure out what Newton's first law of motion says. It has two parts to it. The first part of it, an object at rest will remain at rest unless acted on by an outside force, an unbalanced force. And two, an object in motion will remain in motion unless acted on by an outside force, also an unbalanced force. Okay. Let's see how that works. The first part of Newton's law, an object in motion at rest will remain at rest unless acted on by an outside force. A vase sitting on a table. There's two forces acting on it. One, gravity, keeping it in place, but also the force of the table pushing up on it. And we learned before about balanced forces. Since there's only two forces acting on this object, they're going to cancel each other out, and we have a net force of 0 newtons. Therefore, it is balanced. Our vase isn't going to move anywhere. So an object at rest will remain at rest unless acted on by an outside force. So, if you have a dog come along, right, and it knocks your table, what's going to happen? The vase is going to move because we've added a new force. That new force, therefore, messes up the balance force, and our vase is going to break. Newton's first law of motion also states an object in motion will remain in motion unless acted on by an outside force. So our pitcher throws an object. The object in this case is a ball. Right? It's going to remain in motion. Ignoring gravity, this object would go forever and ever and ever. It would never stop unless acted on by an outside force. The outside force in this case is the batter. He's going to apply a force with his bat. Once that force hits that object, it's going to change its direction and therefore becomes unbalanced. Okay? Unbalanced force hits it, therefore the object's going to move. So an object in motion remains in motion unless acted on by an outside force. Therefore, it becomes the object in motion that will change only if an outside force acts on it. All objects moving or not resist change in motion. This resistance to change in motion is called inertia. Inertia. Okay? Every object that has mass has inertia. Mass is just how much matter an object is made up of. So our flower pot on top of the table has inertia. Okay? It's not moving. It has mass. It's not going to go anywhere. Our baseball, it has mass. It's going to continue going until our batter overcomes that object's inertia and sends it a different direction. How inertia works depends on the mass of the object. As mass increases, so does an object's inertia. A tractor-trailer has a large mass. To get that tractor-trailer to start moving, we have to apply a lot of force. It has a lot of inertia. Okay? No one's going to be able to stand in the back here and just push that truck. It's too big of an object for one person to handle. However, as mass decreases, so does an object's inertia. One person can start pushing a car. Why? Because the car has less mass. Therefore, the car has less inertia. Can overcome that object's inertia by applying less force. Here we would need plenty of people to push because we have a larger object. So we need to apply a greater force. So an object at rest will remain at rest unless acted on by an outside force. An object in motion, think about it. If this truck is moving, has a larger mass, it's going to take more force to stop that car, the truck. Okay? Because it has more inertia. So therefore, we need to apply greater force to stop this because of the object's inertia versus a car. So again, as mass increases, so does an object's inertia. As mass decreases, so does an object's inertia. So the greater the mass, the greater inertia an object has. The less mass, the less inertia an object has.